Hello students, today we are going to start from question number second and question number third. These two questions we are going to finish. First I am taking question number third of exercise 10.4. In the previous session already we have covered a question number 1 and we have seen the two theorems, that is 10.6 and 10.7. 10.6 theorem says the chords which are equal, they are equidistant from the center, and 10.7 says if the chords are equidistant from the center, they will be equal also. Okay, so that theorem we shall utilize in the question number second and question number third also. Once we can see that two theorem, because these two theorems we are using it in the second and third question. So once again let us see both the theorems. We have given that in the theorem 10.6, equal chords of a circle means in a circle we have given that the chords are equal. For example, you can see in the figure the chord PQ and chord RS both are given equal. Then they are saying they are equidistant from the center. Means if you calculate the distance of the chord to the center, in the case of PQ it is OL and in the case of RS it is OM. So OL and OM will be also equal. And the converse part of this theorem, this is if the distance from the center to the chord are same, means if the length of OL and OM are equal, then the chord will be also equal. PQ and RS will be also equal over here. Okay, now let us see the question number third first. Question number third we will do it and then we'll go back to the question number second. So see, in the question number third, we have given that if two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection to the center makes equal angle with the chord. Means we have given that two chords, they are equal but they are intersecting at one point. As per the figure you can see the chords AB and CD both are given equal and they are intersecting at a point E. Then they are saying further prove that the line joining the point of intersection, the line joining the point of intersection to the center, means you focus on that particular line which is drawn between the point of intersection means E and the center means O. So that line makes equal angle with the chord, means line OE makes equal angle with the chord. Now you see line OE makes which angle sorry with the chord AB. Okay, focus on the line AE and the chord AB. If you see it carefully, the line OE and the chord AB makes angle OEL. This angle is marked over here. This angle they are talking about. Okay, similarly the chord CD and the line OE makes angle OEM over there. This angle they are asking. So we have to prove that these two angles are equal, angle OEL and angle OEM. Let us see how we can prove it. Question number second and question number third are nearly 70% are same. Okay, only some further part we have to prove in second question. That's why I have taken the question number third first. Let us see in the given. We have given that in this question. First of all, you see what is given here. The chord AB and CD are equal. So that we will mention chord AB is equal to chord CD. That is one thing given to us. Okay. Now any other thing, we have given that O is the center of the circle and chord AB and CD are intersecting at a point E. So that we will mention here. O is center of circle. O is center of circle and AB and CD intersects at E. Okay, they are intersecting at a point. what we need to prove here? As I have told you, two angles we need to prove equal. So the name of that two angle is, first is angle OEL and second one is angle OEM. Okay, now let us see the proof of the question. First of all, sorry, before proof, one mistake we have done here. We need to do one construction. As you can see, OL and OM are not given in the question actually. Okay, but that OL and OM we need to draw it by our own. Angle OEL is given or angle OEM is also given in the question, but OL and OM, whether this perpendicular we have drawn, this is looking in the figure as a dotted line, so that will be a part of construction. So we will write down in the construction, we draw OL perpendicular to AB, comma OM perpendicular to CD. Okay, so these two things we have done as a part of construction. Construction is applicable in some of the question wherever we are modifying the figure as per the requirement. Now let us see the proof of the question. Now first of all we shall take from the construction. In the proof we'll take here, since OL is perpendicular to AB and OM is perpendicular to CD. Okay, so we know that if perpendicular we draw from the center to the chord, it will bisect the chord, means that perpendicular will bisect the chord into two equal parts. So we will get here, therefore AL is equal to BL is equal to half of AB, because if that two parts are same, then they will be definitely half of AB. Similarly, we shall get here CM is equal to DM is equal to again half of CD. Okay, here reason we shall write down perpendicular from center bisect the chord. Okay, so this reason, this theorem also we have covered in the earlier sessions, so you can check if this theorem you forgot, it is not clear to you. Okay, you can check the previous some sessions where I have explained this theorems particularly. Now let us see this equation we got over here. Okay, now we shall take two triangles. We can see in the figure there are two right triangles we have. One is triangle OLE and second one is triangle OME. Okay, so these two triangles I am taking here first. So first I am writing here in the right triangle OLE, in right triangles OME and OLE. Okay, now first of all you see, we are if we want to prove that two right triangles are congruent, then we have one theorem, name is RHS theorem, or we can say that right hypotenuse side theorem. This theorem says we can apply this theorem only on right triangles, so we also have the right triangles here. Then the second condition of this theorem is the corresponding hypotenuse should be equal. If we look at the triangle OME, then you can observe easily angle M is of 90 degree, and in front of angle M the side is coming OE. So OE will be the hypotenuse, and same way in triangle OLE the angle L will be of 90 degree, and in front of angle L again the same side is coming, that is OE. So we can say that since OE is a common side and hence it is also hypotenuse also, so we can say that it will be equal. So we got the corresponding hypotenuse equal. Second thing, we required one more pair of corresponding side equal out of the two remaining it. Okay, so here you observe, we know that the if two chords are equal, in the beginning of the section I have explained you, if two chords are equal, then they are equidistant from the center. So see, chord AB is having the distance OL from the center. Similarly, chord CD is having the distance OM from the center. So OL and OM will be also equal with the help of that theorem. And now you can say that by RHS congruency theorem, triangles will be congruent. So first of all, let us prove these two triangles congruent here. We can say that hypotenuse OE is equal to hypotenuse OE because it is common. Okay. Now second thing here, OL is equal to OM, that I have explained you. Equal chords of a circle are equidistant from the center. So OL is equal to OM. Reason we can give here, equal chords are equidistant from center. Okay. Then we can say that here, therefore triangle OLE is congruent to triangle OME. This we can say with the help of RHS congruency rule. So by RHS congruency rule. Okay, now the two triangles, they became congruent, and we know that if two triangles are congruent, their remaining corresponding part, whether it is an angle or it is a side, they will be also equal. So observe, angle OEL and angle OEM will be equal with the help of CPCT, and that only we were required to prove in the question. So we can say that therefore angle OEL is equal to angle OEM, that is with the help of CPCT. We can check these two angles are corresponding angles only. If you draw the triangle separately, then both the angles will come at the corresponding location. So OEL and OEM are equal. And see, in the to prove section, we have mentioned already these two angles only we were required to prove. Okay, so this part is over, and we can say that the question number 3rd, whatever the task was given to us, that we have finished. So here question number 3rd gets over. Now let us start the question number 2nd. As I have told you, the second question is also very similar to question number 3rd, only it will have some further part we need to prove it. Yes, in second question you observe, now what we have given to us, if two equal chords of a circle, again you see the chords are given equal, intersect within the circle. Okay, so given is absolutely same. Prove that the segment of one chord are equal to the corresponding segment of other chord. So here you see, actually we are not required to prove the chords are making the equal angle. The line joining from the center to the point of intersection is making the equal angle with the chords, that we are not going to prove. Okay, so we have to prove that the corresponding segments are equal. Now what are segment here? Segment means a part of the chord here. Okay, for example, if you see the point of intersection, the point of intersection is here E. So from the point of intersection we can make two part of both the chords. For example, the chord AB, we can make their two parts. One is AE and second one is BE. Similarly, chord CD can have again two parts. Sorry, one is CE and second one is DE. Now, if you look carefully, in both the chords, one part is longer and one part is little shorter or smaller. Okay, so here we can say that in the chord AB, AE is a longer part. Similarly, in the chord CD, the DE will be the longer part here. So we can say that segment AE and segment DE are corresponding to each other. Similarly, the segment CE and segment BE are also corresponding to each other, and we have to prove these corresponding segments are equal. So first we shall write down the given things here. Here we can do one thing. Whatever the solution we have written in the question number third, that we are going to copy as it is actually. Okay, so first we shall write down chord AB is equal to chord CD. One thing. Second thing, we have written that earlier. O is center of circle, center of circle, and second thing we have written chords AB and CD intersect at E. Okay, now what we need to prove, as I have told you, the corresponding segments we need to prove equal here. So we shall mention here AE is equal to DE, one thing, and second thing we need to prove here CE is equal to BE. Okay, now construction will do it. In the previous question also we have done the construction. Same way we are doing the construction here. You can see the question is going in the same way, only the difference is of the task. What we have proved earlier, we are proving a different things. Here construction is, we draw OL perpendicular to AB and OM perpendicular to CD. Okay, let us start the proof. In the proof, first we'll mention, since OL is perpendicular to AB, comma, OM is also perpendicular to CD, we can do this here by construction. Okay, so we can say that therefore AL is equal to BL is equal to half of AB. In the question number third, actually we didn't use this one. Okay, but in second question, since the use is coming, that's why I have written this equation over there also. So AL and BL are equal and they will be half of AB. Similarly, CM and DM are equal and they will be half of CD. Okay, this can be equation number 1 and this can be the equation number 2. Similarly, now we shall take here, we have taken earlier the two triangles, triangle OLE and triangle OME as the right triangles, and we have proved them they are congruent. The same way we are taking it here in right triangles. In right triangles OLE and triangle OME. And first of all, what we have mentioned there, hypotenuse OE is equal to hypotenuse OE. So that we will mention here also. Hypotenuse OE is equal to hypotenuse OE. That is common. Okay. One thing. Second thing we have mentioned there, OL is equal to OM. Equal chords are equidistant from the center. Equal chords are equidistant from center. Okay, so we can say that by RHS congruency rule, the triangles are congruent. Till here you will observe the proof is going in the same manner. Triangle OLE is congruent to triangle OME. Here we can write down by RHS congruency rule. Now we can say that if these two triangles are congruent, so what we have written in the question question number 3 at last, we have written the two angles equal, angle OEL and angle OEM, we have written equal. But here we shall write down a different thing. Here we shall take the corresponding side. You observe EL and EM will be equal here because they are the corresponding side, and the remaining corresponding side we know that they are always equal in the congruent triangles. So here we shall write down EL is equal to EM. So here we'll write down therefore EL is equal to EM. Reason we can give here CPCT, and this we can give as equation number 3. Now see what we have here. EL and EM we got equal. Okay, and one more thing we have equal here. AB and CD are equal. So if AB and CD are equal, their half will be always equal. And who will be the half of AB here? AL or BL. Similarly, who will be the half of CD here? CM or DM. So we shall write down. Now we are going to prove the first part. AE is equal to DE. Okay. So first we shall write down. Now since AB is equal to CD, it is given in the question. Okay, this we can write down as given AB and CD are equal, or else we can say that AL is equal to DM. See why I am taking AL and DM here, or how I can take AL and DM. See, AL is a half of AB, and second thing, DM is a half of CD. You can check in the equation number first and second. AL will be the half of AB while DM is the half of CD. And we know that if two sides are equal, their half will be also equal. So here we can say that half of equal sides. Half of equal sides. Okay, so AL and DM are also equal. Now this I will give as equation number 4. So we will add equation 3 and equation 4. So we can write down adding equation 3rd and 4th. So here when we will add, remember the left hand side will be added to the left hand side and right hand side will be added to the right hand side. So this will become as EL plus AL is equal to EM plus DM. Okay, now EL plus AL, you observe what we shall get. Look at the figure first. EL plus AL, observe carefully. EL plus AL will become here E to a complete length, is AE. Similarly, EM plus DM will become here DE. Sorry. So here we shall write down EL plus AL as AE and EM plus DM as DE. So we can say that this will be equal to AE and this will be equal to DE. Here we can say proved first part. Okay. Now again we are going to prove the last part. AB is equal to CD. AB and CD are equal. Okay. Now AB I can break into two parts. One is AE and second one is BE. So AB I am writing as AE plus BE. Similarly, CD I can write down as C plus DE. Okay, and you can see earlier we have proved AE and DE are equal. This I can give as equation number 5, and AE I can replace it by DE plus BE I am keeping as it is. Similarly, CE will be as it is, DE will be also as it is. And the reason we can give it by equation number 5. In place of AE, I have written only DE. So now you observe DE and DE. We can cancel. So we can say that therefore BE is equal to CE. That is only the second part we were required to prove. Okay, you can check in the second part, BE and CE only we were required to prove in the question. So this was the additional part we have proved in second question. Okay, next time we can start the question number 4 onwards. Thank you.